Number 5 says that 3 pi over 2 compute to six basic functions. 3 pi over 2 is right down here, and this would be 0, negative 1. Now our sine, I just put t to indicate the angle. Actually, sine of 3 pi over 2 is going to equal to our y value, which is negative 1. Cosine of 3 pi over 2 is going to equal to our x value, which is 0. Tangent of 3 pi over 2 is equal to y over x, which is negative 1 over 0, which is undefined. Cosecant of 3 pi over 2 is going to equal to 1 over y, which is 1 over negative 1 or negative 1. Secant of 3 pi over 2 is going to equal to 1 over x, which is 1 over 0 or undefined. Cotangent of 3 pi over 2 is equal to x over y, which is 0 over negative 1 or 0. And it says check cosine squared plus sine squared, secant squared minus tangent squared, cosecant squared minus cotangent squared. Not sure what they mean by that, unless just plug in the values, I guess. So cosine is 0, so we got 0 squared plus sine, which is negative 1. So we got 0 plus 1 or 1. Secant squared minus tangent squared, and that's assuming this these same values. Now secant we said was undefined, so we got undefined squared minus tangent squared, which is undefined squared. So this is undefined. And where is it at? Cosecant squared minus cotangent squared. Cosecant is negative 1, so we've got negative 1 squared minus cotangent squared, which is 0, so that gives us 1. I think what they're trying to do here is to point out that these would normally all give you 1, except here where we got secant and tangent. Secant and tangent both have x in the denominator, and where x is equal to 0 is undefined. So this is the one where Pythagorean identities doesn't hold true. Let's see what number 6 says. Prepare a table showing the values of 6 basic functions at 0, pi over 4, pi over 3, pi over 2, pi. So we got 0 here, which is 1, 0. Pi over 4, which is right here, which is square root of 2 over 2, and square root of 2 over 2. Pi over 3, which is 1/2 square root of 3 over 2. And pi over 2, which is 0, 1. And then pi, which is negative 1, 0. And prepare a table showing the values of the 6 basic functions. Theta. And we got 0. Now that's 0 degrees, or I guess we're in radians. Okay. So we got sine. Now sine, here's our first point we're looking at. Sine is our y part. So sine is going to be 0. Cosine is going to be our x part, which is 1. Tangent is sine over cosine. 0 over 1 is 0. Cosecant is 1 over y, and y is 0, so that's undefined. Secant is 1 over x, so that's 1 over 1 or 1. And cotangent is cosine over sine or x over y, but either way it's undefined. And then pi over 4. Sine of pi over 4. Sine is your, we're looking at this point here now. Sine is your y, so that's square root of 2 over 2. Cosine is your x, that's square root of 2 over 2. Tangent is sine over cosine, square root of 2 over 2 over square root of 2 over 2 is 1. Now cosecant. Cosecant is 1 over y, which is 1 over square root of 2 over 2. You got a fraction down here, you flip it and multiply times your top part. You got 1 times 2 over square root of 2. Multiply it top and bottom by square root of 2, and you get 2 square root of 2 over 2, which is square root of 2. Cosecant is 1 over x, which is the same thing. And cotangent is x over y, which would be 1. And I won't go through and complete those, but that's what they're looking for in that one. Using the same formulas that I gave you up here. 7. I don't know if I remember the formula for this. The area of the circle is pi r squared. Area is equal to pi r squared. What is the area of the sector that has angle theta? It is a fraction of the whole area. The area of the sector that is angle theta. So if that's theta, then we're wanting to find this area right here. I think it's just given by a formula. Except for I'm really drawing a blank on what that is. It involves S. Pi. I don't know. I won't be able to help on that one. I'd have to. If you Google it, you'll find the area of the that, but I don't remember it, to be honest. It's just get really close. Okay, find distance from that to that along a straight line, quarter circle, semicircle, centered at S is equal to 2. I don't remember the formula for that. I think it's S is equal to 2 pi over R. Here, if you just look at the length of a, let me look here. It's not a sector. I think it starts with S. If I had my trig book handy, I could look it up. Okay, let's look it up. Trigonometry, area of a sector. And along with that should be arc length. So I'm drawing a blank on. Now our formula, I guess arc length is pi over r. So is the area. Sector area is theta over 2 times r squared. So this is what you'd want to, of course it depends on what you're dealing with. If you're dealing with degrees, it'd be this formula. If you're dealing with radians, is this formula. To find the distance of that arc length, then you'd use these. Pi over r. And, where's the book? There we go. So when they're saying along a straight line, that's just the distance formula. When they say a quarter circle, then they're talking about quarter circle. Here's a complete circle. Oops. Quarter circle would be this piece right here. And so for our distance, arc length, it's S, is how they represent that. That's arc length is this right here, and it's S. S is equal to pi, theta r. And if it's, this is in its radians. So this right here would be pi over 2 times r. I don't remember if they give you r. A straight line, a quarter circle. Oh, distance from 1, 0 to 0, 1. Which means that the radius is 1. So S would equal to pi over 2 times 1. Okay, that's a quarter circle. What are the other ones? Semicircle. What in the world is a semicircle? Centered at 1/2, 1/2. You'd have to go look up what a semicircle is. I don't know what that is, to be honest. This looks like the distance formula again. And the distance D will give you this. And show on a circle why 6D is less than 2 pi. I'll think on that one. And this one. Oh, that's figure 1.22. Compute D squared. So what in the world's D? Because this looks like the unit circle. And if D is a diameter, then D would be all the way across, which would be 2. Oh, D is this arc length right here. So I'd go back to your arc length formula. Oh, and this right here, 6D is less than 2 pi. That must refer to your arc length again. So, again, that goes back to that formula. Those should give you some hints to doing that. Let me know if that doesn't help.